So today, we'll start with respect to one more interface in collections, that is set interface. Okay. In previous sessions, we saw that what is a list interface, and we saw its implementing classes, array list, and linked list. Right. So today, let us see with respect to set interface in Java. Okay, where basically it is also an interface or a data structure which helps us in storing the data. Okay, where we will be using the set interface for storage of the data. Okay, so the set interface, the set interface in Java is a part of the Java collection framework and is an interface. Interface is nothing but which defines methods where implementation of those methods will not be present. Okay, and we will be inheriting those particular interfaces to define something, right? So like that we have set interface. So that represents a collection of unique elements. Here duplicates are not allowed. It is found in java.util.package. It is found in java.util package. Okay. So basically when we go with the set interface, we go with the set interface when duplicates are not allowed. Okay. In that particular case, we go with set interface when unique elements should be stored. In that case, we go with the set interface. Now, the set interface has three implementing classes. Okay, one is hash set, one is linked hash set, and the other one is the tree set. Okay, so the hash set is the one where unordered collection and no duplicates are allowed and no null values are allowed. Okay, for example, when we use hash set basically uses hashing mechanism to store the elements. Okay, and in hash set the duplicates are not allowed and insertion order is not present. Now let us see these three implementing classes one by one, and we'll see these methods whatever we have defined with respect to this implementing classes with respect to set, that is hash set, linked hash set, and tree set. Okay, so first start with respect to hash set. Now hash set is a collection that uses a hash table for storage. Okay, and it does not maintain any order of elements that we have inserted and does not allow the duplicate values. Okay, so what is hash set? Hash set is nothing but it is a collection. It is an implementing class that implements the set interface. Okay, and it uses a hash table for the storage of elements, and it does not maintain the insertion order in which the elements are inserted and does not allow duplicates also. Okay, so let me try to switch to Eclipse and try to show you guys that how does the hash set work. Okay, so how to create any collection class object, how to create any collection class. So for that we have to use creation of object with the help of new keyword. Okay, so hash set like this. Okay, and what type? Suppose I need to store only integer values, so I'll use the non-primitive data type integer, and I'll give one reference variable hs is equals to new hash set like this. And we have to again define the non-primitive data type, that is integer, and constructor called open close. Like this we will be declaring any class in an collection concept. Okay, let me try to import java.util.hashset. Okay, I have imported. So this is how we will be declaring a hash set. How to declare? With the help of hash set, the data type, the reference variable, the new keyword, then again the constructor call with respect to the data. This is how we will be creating a hash set, and it is common throughout the collection concept the way that we create any object to the collection class. Okay, so this is a hash set. So now we have created a hash set. Now what is the characteristic of a hash set? The characteristic is duplicates are not allowed. insertion order is not preserved. Okay, so that is the characteristics of a particular hash set, and there are different characteristics with respect to different classes in the collection. But what is the characteristics of a hash set? Here insertion order is not preserved and duplicates are not allowed. Now let us try to insert some elements. Now what is the method that we have to insert an element? Add. Okay, hs.add. I'm trying to insert some values. Let me try to insert 1. Let me try to insert like this. Some values let me try to insert. Okay, like this. I'm just trying to insert. So now let me try to change the values. Here I have inserted 1. Here let me try to insert 12, 14, 10. Okay, here let it be 2, here let it be 6, 9, 0, 9, 8, 6, 8 and 5. Okay, now let me try to execute this. Okay, so execute in the sense, let me try to print the object, that is hs. Okay, so I'm just trying to print this hash set reference variable. So this will give me what and all the elements that I have stored in the hash set. Right click, run as Java application. See, now here you can see that we have seen this particular insertion of elements. Now first let us try to see what is the order in which we have inserted the elements. Okay, before going to the console output that we have printed, let me try to see the order in which we have inserted the elements into the hash set. What is the order? Order is 1, 12, 14, 10, 2, 6, 0, 9, 6, 8 and 5. This is the order in which we have inserted the elements. Right, here we have the same order, like we have first time we have inserted 1, then 12, 14, 10, like that. Right, so this is the order in which we have inserted the element in the hash set. Right, are we seeing the same order? No, we are not seeing the same order. Right, because whenever we insert an element into the hash set, the order of insertion in which the user or a programmer has inserted will not be retained, because the hash set uses the hashing mechanism to store the elements, due to which the order in which a user has inserted will not be present. Okay, so hence you can see that the output is something like this: 0, 1, 2, 5, 6, 8, 9. In some random order it has inserted. Okay, don't consider that it is an ascending order. No, it is not an ascending order. Okay, it will not store, hash set will not store the elements in ascending or descending order. No, it will store the elements based on the hashing mechanism, where insertion order of the elements is not present. Okay, so that is basically hash set, where insertion order is not preserved and duplicates are not allowed. Only unique elements are stored. For example, if you see here, we have inserted 6 two times. Right, at line 15 we have inserted 6, at line 18 we have inserted 6, but in the output we can see that the 6 is only one time. Right, because the hash set does not allow the duplicate elements. It will only allow the unique elements with respect to the hash set. So that is the major concept of hash set, that when the requirement is duplicates are not allowed and insertion order is not a criteria, in that case we go with hash set class. Okay, let me try to see the characteristics with respect to the hash set. What are the characteristics? We have no duplicates are allowed and unordered, that is no guarantee of the insertion order, and allows null value. Only one null value is stored, because even though if you are trying to store multiple null values, it will not allow duplicate. So due to which only one null value is allowed. For example, like this, suppose if I am trying to insert one null value, like hs.add of null, like this if I'm trying to store. Okay, and let me try to store one more null value here. Okay, two null values, but as this hash set will not allow the duplicates, so it will just allow one null value. See, like this, right? So insertion order is not a criteria and duplicates are not allowed. In that case, we go with hash set. Okay, now for example, consider there is an array of elements. Okay, there is array of elements, for example, like this integer array a is equals to something like this, right? We have 2 5 4 7 2 4 9 10, like this, and the requirement is that need to remove duplicates elements from an array. Suppose consider this is a requirement. So how to go with this requirement? We can just try to declare one hash set and we can iterate the array and we can insert all the elements. Need to remove duplicate elements. Okay, need to remove duplicate, not all the elements, duplicate elements from an array. Okay, in that case. Now what I will do? I will declare one hash set of what type? Of integer type, because I need to store integer values. I'll give a reference variable, assignment operator, new keyword, hash set, constructor call. Like this, I'll try to declare one object of hash set. Now I will make use of for loop for int of z colon a. I've taken advanced for loop and now we'll try to insert all the elements of array into the hash set. Okay, all the elements. So all the elements are inserted. Now if I'm trying to print the object hs, which is an hash set object, it will give me only unique elements. It will not give me any duplicate values. See, like this. So what is the use, or when do we go with hash set? When insertion order is not preserved or insertion order is not a criteria and we have to remove the duplicates or we have to store unique elements. In that case, we go with the hash set. Okay, so this is a hash set class which implements set interface, which is implemented by using hashing mechanism. Okay, now let us see with respect to the linked hash set, the one more class. See, this is the common use with respect to hash set. It removes duplicates from a collection. Okay, now let us see linked hash set. Linked hash set is a subclass of hash set that preserves the insertion order of elements. Okay, even though it stores the insertion order, but no duplicates are allowed in the case of linked hash set as well. Okay, now let us see how to implement it. Very simple. We just have to add linked, like this. Linked hash set, data type integer, reference variable, the assignment operator, new key. Like this we can try to insert linked hash set. I think h is small, or let me try to see how it works. Okay, so linked hash set, like this. Okay, linked hash set, right? So this is linked hash set. Now what is the insertion order in which we are doing? We are doing in this way: 2 4 5 7 2 4 9 10, right? Okay, let me take it simple example like this. Let me try to remove everything whatever we have, and let me try to go from starting. Okay, so how to create an linked hash set? Simple, linked hash set, right? Let me try to import. Now once we have created, we have to insert some elements into the linked hash set, right? So let me try to insert with the help of method add. Add is the method which helps us in insertion of elements. Okay, so I'm trying to insert. Let me try to insert 12. Let me try to insert 13. Let me try to insert some other elements here. Okay, so this is the element that I'm trying to store, like this, and let me try to give it as 120, 155, 112, 128, 198, 178. Something, some values I have inserted. Now let me try to print. So that is linked hash, LHS. Okay. So what is the order in which we have inserted the elements? The order is this one, right? We have inserted the element in 12, 120, 125, 1, 12, okay, 128, 198, 178. Now what are the duplicate elements? 12 is the duplicate element. So let me try to remove the duplicate like this. Let me try to save. The insertion order is 12, 120, 125, 128, 198, 178. This 12 is a duplicate value, so it will not be inserted. Okay, run as Java application. See, the same order in which we have inserted. Are we getting? So what is the major difference between linked hash set and hash set? Linked hash set stores the insertion order in which the elements are inserted into the linked hash set. Whereas in the case of hash set, insertion order is not present. Okay, and duplicates are not allowed in both the cases. Duplicates are not allowed with respect to linked hash set or even with respect to the hash set. The duplicates are not allowed. Whereas in the case of hash set also duplicates are not allowed, right? So the duplicates are not allowed, insertion order is preserved. Now let us see with respect to null value, LHS dot add of null, like this I'm trying to insert. So I think it will allow us to store one null value because duplicates are not allowed, right? If suppose I'm trying to insert two null values, okay. So insertion of duplicate null values. So linked hash set will not allow insertion of duplicate null. Okay, it will allow only one null value to be stored like this. Run as Java application. See, it is allowing us to store only one null value, right? Why it is not allowing at the last? Because we already have, right? So that is the reason when do we go with linked hash set. Now let us see what are the characteristics of linked hash set again. Okay. So the linked hash set will maintain insertion order and no duplicates are allowed. And what is the characteristics? The characteristics is no duplicates are allowed. Okay, and it maintains insertion order and allows one null element. And when to go with the linked hash set? When we want elements to stay in the order in which they were added. Okay, in that case we go with the linked hash set. Okay, so when do we go with linked hash set? We go with the linked hash set when we want the elements to stay in the order in which they were added. And when duplicates are not allowed, that is anyhow the characteristics of a set interface, right? So that is the use of linked hash set. What is the difference between hash set and linked hash set? Insertion order. Simple. Here insertion order is preserved. In the hash set, insertion order is not preserved. Duplicates anyhow are not allowed in the case of set interface. So consider it is a common characteristics. Set, duplicates are not allowed. Now difference between hash set and linked hash set. Insertion order is not preserved. Insertion order is preserved. Simple. Okay. Now let us see with respect to the tree set in Java. Okay, before going to the tree set, let us see how to extract each element in Java. Okay, how to extract each element. We don't have here get method as we have the method with respect to list. We don't have get method here. We have to make use of iterator. Okay, what we have to make use of? We have to make use of iterator in order to iterate each element in a set collection. Okay, each element. We have to make use of what? We have to make use of iterator. Now let us see how to create that iterator. Now what is the object? What is the set object that I want to iterate? What is it? It is LHS is the reference, which is the reference object of linked hash set, right? So dot iterator. What I'm trying to do now? I am trying to access each element in a set, or each element in the implementing classes of set interface. In our case, what class we have taken? We have taken linked hash set. Okay, so I'm trying to iterate each element that is present inside a linked hash set, right? So for that, what I'm trying to do, I'm trying to use the reference variable LHS dot iterator. Iterator is a method which will return us iterator like this. Okay, iterator, it will return us iterator, which is an interface, and it will take the type that this particular element stores. What is the type LHS store? It stores only integer values, right? So it will take that type, and this is a reference variable. I'll take it as IT like this. Okay, so this is how we can try to iterate each element present in a set object. Okay, LHS is the reference, iterator is a method. Now what is the return type? The return type is the iterator interface with the type in which we are trying to store the elements in this particular reference. What is the type of data? Integer. So that it will take. Now by using this, can we print? No, we have to loop this particular IT. I'll go with while loop. While open close braces. Now IT dot has next. So the has next is a method which will try to check if the elements are present inside the iterator or not, or in the linked hash set or not. For example, if first it will try to point to this particular value 12, then next it will try to point to 120, then next it will try to point to 125. Like that, it will try to point to each element inserted inside an set object. In our case, it is linked hash, right? So iterator dot has next is a method which will try to check, or it will try to return true if an next element is present. It will return false if there is no elements inside a set object. In our case, it is linked hash set. Has next. Boss, check whether next element is present in the object that it has created with. Okay, so what is, do we have first object? Yes, we have 12. Like that, it will traverse like this and it will come to null. In our case, the null will not be stored. Let us consider 178. Okay, it will point to 178 and it will check, do we have any next element? No, we don't have the next element. Return false. In that case, it will return as false. While loop will be terminated. Okay, now let us try to make use of one more method, that is it.next. Next is a method which will tries to print that particular, that will try to point to the element which we have to iterate. This will it.hasNext will check whether do we have next element. It will not extract. This next method will extract and give us. It will return the next element in the iteration. It will just check whether we have a next element. It will return us. It will give us the next element. Okay. Now let me try to print run as Java application. See, we have extracted each element inside the linked hash set. Each element like this. So how to use iterator? We have to use LHS, which is the reference variable dot iterator is a method which will return us iterator and the type of values that we have stored in the set object. Then we have to make use of one reference. Then we have to make use of a while loop, and then we have to make use of the reference of the iterator and try to check is there is a next element present. Okay, it.hasNext is just used to check whether there is a next element present inside a set. Then this next element, this next method, which it will help us in extracting each values from a set object. Okay, So this is how we iterate each element in a set, because we don't have an inbuilt method with respect to dot get in set concept, as we have with respect to list concept. In list we have list object dot get of index also we have. So we can use that and we can directly extract the element. But in the case of set, we don't have such kind of inbuilt methods. We have to make use of iterate. Okay. So this is the way that we try to iterate each element inside a set interface of the set implementing classes. That is, you can iterate. If we have to use this iterators in order to extract and validate the values inside a set, which might be with respect to hash set, which might be with respect to linked hash set or tree set. Okay, so now let us go with respect to the characteristics of linked hash set. So the characteristics is no duplicates are allowed, it maintains the insertion order. And when to go with the linked hash set? When the elements to stay in order in which they were added. In that case, we go with linked hash set.